Today we are going to talk about surveys. As we're going through this section, the big thing that we're going to focus on is our different vocabulary words that we are going to see as we're going to use these different ideas as we're going through kind of the more substantial sections in Chapter 7. Right. So in chapters 2 and 3, we talked about data summary techniques. So that's where we talked about a bunch of our different types of graphs and visualizing different distributions. In chapter 5, we talked about probability, and in chapter 6, we talked about our normal distribution. What we're going to do in this chapter is we're going to actually combine a lot of these different ideas. We're going to start with today kind of using stuff that we talked about in the early chapters as far as some of our different distributions and things like that. We're going to bring up some of the vocabulary that we talked about previously in other chapters. And then as we move into section 7.3 and 7.4, that's where we're going to move into a big discussion of our normal curve that we saw back in chapter 6. Right, so to begin with, we're going to start with a few definitions. Right, so our first definition is going to be that of a population. A population is a group of objects or people who we want to study. When we're thinking about the word population, what we should be thinking about is this is all, right? So an entire group, an entire population of people, right? A parameter is a numerical value that characterizes some aspect of the population. Right? So the parameter is the number part that goes with our population. Parameters can include means, standard deviations, or proportions, and we're going to talk a lot about our different notation for all of these. Right? A census is a survey which measures every member of the population. So as we're thinking about these, a census is a survey which measures every member. The one thing with census or with taking a census is it's very difficult if you have a very large population. All right, so in example 1, data is gathered on the heights of all NBA basketball players. The mean of the data is calculated to determine the population and the parameter. So the population is our group of people. So in this case, our population is all NBA basketball players. Our parameter is the number that's being associated with this population. So in this case, our parameter is the mean height of all NBA basketball players. So again, our population is our group. So in this case, our population is all of our NBA basketball players, and our parameter is the number that goes with this. So that is the mean height of all of these NBA basketball players. Right now, as I've already mentioned, it can be difficult to study an entire population. It can be difficult to find parameters. It can be difficult to do a census of an entire population. So a lot of times, instead of looking at populations, we use samples. Right? So a sample is a collection of objects or people taken from the population of interest. Most populations are too large for a census, so we study populations by measuring samples instead. The numerical part that goes along with this is our statistic. So our statistic is a numerical value that characterizes some aspect of our sample. Statistics include the sample mean, the sample standard deviation, the sample proportion. Same thing that we saw for our population. The only difference is one of these is about our mean, one of these is about our population, one of these is about our sample. Sometimes a statistic is referred to as an estimator because it is used to estimate values of a parameter. So as we're going through this section, kind of one of the big things that we're focusing on is our vocabulary. So we want to know the difference between populations and parameters versus samples and statistics. So our populations and parameters, again, we're thinking all. Our samples and statistics, we're thinking of a smaller group. All right, so in example 2, A researcher is interested in studying the heights of American women. She takes a random sample of 1,500 American women and finds the mean height of the sample is 63.6 inches. Determine the sample and the statistic. So our sample is the 1,500 American women. So our sample is our smaller group. Our statistic is the sample mean of 63.6 inches. Okay. The researcher may estimate that the average American woman is 63.6 inches tall. So we can use our sample statistics to make estimations. Right, remember our mean is our average, so we could estimate that the average woman is 63.6 inches tall. In this next example, we are going to compare our populations and parameters to our samples and statistics. So in January 2015, the Pew Research Center published a report stating that 37% of Americans believe that genetically modified foods were safe to eat. This was based on a survey of 2002 adults. Identify the population in the sample. What was the parameter of interest? What was the statistic? All right, so our population, again, when we're thinking about population, we're thinking about the word all. So our population is going to be all American adults. Our sample is our smaller group. So in this case, our sample is the 2002 American adults that were surveyed. So again, our population is our group of all. Our sample is the group that was surveyed. Our parameter, what we're thinking about, what we want to estimate, or what is being estimated here, is the percentage of American adults who believe GMOs, right, are safe to eat. Our statistic is the 37% of the sample who feel this way. So again, our population is all, our sample is the smaller group. So all American adults versus the 2002 that were surveyed. Right, our parameter is what we're estimating, the percentage of American adults who believe GMOs are safe to eat. Our statistic is our estimator, right? So 37% of the sample who feel this way. Right, down at the bottom, we have another vocab word that we're going to look at. Parameters, as we've mentioned a couple of times already, are hard to find. It's hard to collect data from the entire population, so we use statistics because they're easier to find. Right? And we have a word for this estimating that we've been talking about. Right? So we call this statistical inference. Right? So statistical inference is a science of drawing conclusions about a population parameter based on our statistics from our sample. Anytime we're drawing these types of conclusions, there will be a little bit of uncertainty because we're not measuring our entire population, we're making an estimation, right? And in the word estimation, we're thinking there is a level of uncertainty, right? And as we're doing this, as we're thinking about this estimation and as we're thinking about this uncertainty, one thing that we're going to talk a lot about as we get into the next few sections is a way to measure this level of uncertainty. All right, looking at the top page, the next page in our notes, we see the comparisons between our statistics and our parameters. Again, statistics are based on samples, they're based on data. Parameters are based on populations. Again, they're typically unknown. That's what we are trying to estimate. As far as our notation goes, we should see some notation that looks familiar. We've talked about our sample mean and sample standard deviation back in chapter 3. We use the X bar and the S for our notation. In the previous chapter, in chapter 6, when we were finding our z-scores, when we were talking about our normal curves, we used our population mean of mu and our population standard deviation of sigma. Right? So the same notations that we've seen in previous chapters we're going to continue to use. The one that we're going to add in is our p and our p hat. The p stands for proportion, a proportion or a percentage, right, as we're looking at these. So our p hat is going to be our sample proportion, and our p without a hat is going to be our population proportion. Both of these are lowercase letter p's. So p hat for our sample, p for our population. All right. In addition to our vocab words of population and parameter versus statistic and sample, the next thing we're going to look at is bias. Right. So a survey method is biased if it has a tendency to produce untrue values. We're going to talk about two different types of bias, one of them being measurement bias, one of them being sampling bias. So our first one here is going to be our measurement bias. Measurement bias results from asking questions that do not produce a true answer. Right? The biggest kind of easiest way to figure out if something is measurement bias, we are looking at whether or not it gives people an opportunity to lie. So possible sources of measurement bias, self-reporting of personal data, using confusing wording in a survey, or the use of non-neutral language in questions. So people either lie when they are self-reporting the data, and or the question is presented in a way that it gives untrue answers because of either confusing wording or non-neutral language. Our other type of bias is sampling bias. Sampling bias occurs when the sample does not represent the population. A couple of possible sources of sampling bias, response bias. People only respond when they are passionate about a topic. Right? So people either feel strongly one way or the other about a topic and they respond. Or non-response bias. A large percentage of those surveyed do not reply. All right, so in example 4, we're going to look at our different sources of bias. Right? So in these examples, and you'll see some of these in your homework problems as well, we're asked to identify possible sources of the bias, and we're going to be kind of specific as we describe whether it's measurement bias or sampling bias, and why that is the case. Right? So for example A, a survey asked people to report how much they weigh. This is going to be an example of measurement bias. Remember, measurement bias, right? The questions do not necessarily produce a true answer. So a survey asked people to report how much they weigh. Well, this is an example of measurement bias because people could very easily lie about how much they weigh. So this would be an example of measurement bias caused by self-reporting of personal data. Right, example B. A teacher at a community college sent out questionnaires to evaluate how well the administrators were doing their jobs. All teachers received the questionnaires, but only 10% returned them. Most of the returned questionnaires contained negative comments about the administrators. Right? So in this case, this would be an example of sampling bias. Sampling bias we categorize as either non-response bias and or response bias. Non-response bias means not a lot of people responded to the survey or replied to the survey. So this would be a case of non-response bias because we only had 10% that returned them. And most of the return questionnaires contain negative comments. So this would also be an example of response bias. Right? Because in response bias, we only respond if we are passionate either one way or another about a topic. So we're going to say that this is a sampling bias, and it is both non-response and or response bias. Right? We don't get a lot of responses, and the ones that we do, right, are generally all negative. A hotel gives an internet poll to rate the hotel's performance. This would be another example of sampling bias. Chances are, unless there was some sort of incentive, right, a lot of times with internet polls or polls on your cell phone or about different apps or things like that, right, we don't generally get a large response. And if we do get a large response, it's because you either really, really like something or really, really don't like something. So we're going to say that this is most likely could be either non-response and or response bias as well, right? Depending on how many responses we get and or what those responses tend to be. A school district sends out a survey to all school parents asking, do you favor the passing of school bond measure to provide additional resources to improve educational opportunities for your student? Right, this one actually represents both types of bias. Right, so we could say that this represents measurement bias. Measurement bias, again, gives us an untrue answer. Right? And measurement bias can either be self-reporting of personal data, as we saw in our first example, or the wording of the question. So this is not necessarily confusing wording, but we are using non-neutral language in our questions. Right? So that may cause people to answer the question in a particular way. This could also be a case of sampling bias, as in the last couple of examples. Okay, it could be a matter of non-response and or response bias, depending on the types of responses that are received and how many of those responses are received. Right. So as we are doing different problems and as we are thinking about our populations and parameters versus our statistics and samples, what we want to do is we want to provide the best answers that are possible. We want to provide the most representative survey, right, of our population using our sample. So as we're thinking about these different things, a few things we need to ask as we're talking about are thinking about doing a sample or collecting a sample to represent a population. What percentage of those asked to participate actually did so? Right? So here we're thinking along the lines of sampling bias. And did researchers choose people to participate in the survey, or did the people choose to participate themselves? Right? If a large percentage of people who were asked refused to participate, or if the people themselves chose to participate, the conclusions of the survey are suspect. Right? Because then we are looking at non-response and or response bias. All right, so one way we can avoid bias, right, is our simple random sampling. Simple random sampling, sometimes abbreviated SRS, helps to eliminate our sampling bias. When we're using simple random sampling, we draw subjects at random from the population without replacement. So the key thing is here we're thinking without replacement, because we don't want to ask the same person twice. So if we ask one person, after we're done with that person, we need to move on to somebody else. So we're thinking without replacement here. This is the best way to select a sample because every member of the population is equally likely to be chosen. But the only problem with this is a true random sample is difficult to achieve. So how we're going to find these truly random samples, we're going to use our random number table that we saw back in previous chapters. Right, so in this first example, you need to select a random sample of 4 students from a small class with 7 students. We will do this using the random number table. Right, so we're going to assign each student a number from 1 through 7. We could do this with 2-digit or 3-digit numbers as well. Instead of just selecting individual digits, we could select groups of digits. But we're going to assign each student a number from 1 to 7. Start at a given line in the random number table and select numbers until 4 of the given numbers are chosen. All right, so I've just selected a line in our random number table to start with rather than putting the whole table in here. So we're going to choose 4 students out of these 7. All right, so the first student that we're going to select is the student that's represented by the number 1. The next student that we're going to select is going to be the student represented by the number 3. We don't have students 8 or 9, so we can't use those. We've already selected 3, so we can't select 3 again. We don't have any students that are assigned the number 0, but we do have a student that's assigned the number 6, and we do have a student that's assigned the number 2. So our random sample would include the students assigned numbers 1, 3, 6, and 2. So our random number table we can also use to find random samples. Down at the bottom of this page is a way of entering our different things in StatCrunch. We can also generate a simple random sample that way. Enter the assigned numbers into the first column. Go to Data, select Sample. We're going to select the column at the top of the window, enter the sample size, and then select Compute. And then in our table in StatCrunch, we're going to get a new column that actually has our random sample that's listed. This is a way that works if you're doing a small sample. A random number table might be quicker and easier. We're not going to do a lot using StatCrunch. If you were to go in here, kind of the big thing to think about is if we repeat the simulation using StatCrunch, we're going to get a different random list every time. So if we were to go through and do this example using StatCrunch, we're just going to say that our results will vary for every repetition. So a couple of different ways of generating our simple random samples. We could use things such as a number table, or we could use technology to generate these samples. Right, so the key things we want to think about in this section, the idea of population versus parameter, and sample and statistic. Right? Again, population is all. A sample is a smaller group out of that population. And as we're choosing our samples, we want to do so carefully, right, to avoid bias. So we want to choose our samples to avoid our measurement bias and sampling bias that we already talked about.